Today, we are going to learn how to interpret p-values in RStudio using the iris dataset. For linear regression to be accurate and effective, the relationship between the two variables must be in a linear pattern. In order to figure out if the two variables share a linear relationship, we must use the p-value. If the p-value is greater than 0.05, then it shows that there is no significant linear correlation between the two variables. If the p-value is less than 0.05, there is a significant linear correlation between the two variables. This is because the p-value signifies the probability that the result of a linear relationship occurs by chance. If the p-value is low, the higher chance that there is a significant linear relationship. To find the p-value of a regression, we will use the summary function. However, before we start with the summary function, we need to have a regression. I covered linear regressions in a previous video. In my first linear regression, I have my independent variable as sepal width and my dependent variable as sepal length. In my second linear regression, I have my independent variable as petal underscore length and the dependent variable as sepal underscore length. For my first regression, called regression 1, I will write summary in parentheses regression 1. Now, we will run the code. Once you run the code, you will see many figures, and it may seem quite intimidating. However, the only number that we need to be aware of is the p-value of your independent variable. Mine is sepal underscore length, and value PR in parentheses greater than an absolute value t. So, the p-value for this linear regression is 0.152. And if you look beneath the p-value, you will see the significant codes, which is right here. 0 is triple asterisk. 0.001 is double asterisk. 0.01 is single asterisk. 0.05 is period. And 0.1 is nothing. If you remember from the start of the video, or if you can see from the significant codes, the two variables do not have a linear relationship. If we use the plot function to create a scatter plot, we can clearly see the reason. I covered how to make scatter plots in a previous video, but for a refresher, type plot in parentheses your independent variable. Mine is sepal underscore width, comma, and your dependent variable. Mine is sepal underscore length. Now, let's run it. When you see the graph, you can see a slight possibility of an increasing linear relationship from 2 to 3, but it seems to reset after 3. It is also generally too scattered and spread out to be any linear relationship. For regression 2, we will use the same process. So, summary in parentheses regression 2. Now, let's run the code. Once you run the code, you will see that the p-value is 2e negative 16, right here. 2e negative 16 means that the p-value is so small that it is past the minimum value that R can process. This number is also much smaller than 0.05 and has 3 asterisks. This means that there is an incredibly close correlation and linear regression is effective between these two variables. You can see this when you create a scatter plot of the two variables. So, following the same instructions as before to make the scatter plot, so plot in parentheses your independent variable, which is petal underscore length, comma, your dependent variable, sepal underscore length. And then when you hit run, you can see a very clear increasing linear trend. As you can see, there is a bit of grouping towards 1 through 2, but in general, there is a quite clear increasing linear relationship throughout the graph. So, we now know how to use the summary function for linear regression, interpret p-values to find the effectiveness of linear regressions, and scatter plots to visualize possible trend lines. Thank you for watching. Please like, share, and subscribe.